Hello everyone, this is your guy Rajat. So I am back again with yet another video. So today we are going to learn about closures in JavaScript. Now don't be worried if you are seeing the change in my desktop environment. It is actually Ubuntu GNOME or GNOME, whatever it is, and I will be producing a separate video about how you can install Ubuntu GNOME instead of regular Ubuntu. Okay, so don't be worried, and our JavaScript setup, that is Node.js, is going to be the very same old tool. Okay, so let's get started. So what are closures? You can consider closures as a secret variable which any function has access to. So let's just quickly see visually that what I am talking about. So let's launch our favorite tool, terminal, and then launch node. Okay, oops. Okay, all right, let's create a class. Now if you're not aware of the let keyword, make sure you watch my previous video where I have talked about this let keyword. Okay, so let's define a new function, okay, and let it contain a new variable, that is private, and the value is 42. Okay, and let's return a new function, an anonymous function to be more appropriate, and just return private. Okay, so what have we done here? We have defined a function, and in that function we have defined a private variable. Okay, and we have defined yet a function which is going to be returned, and that function is going to produce the value of private whenever the user makes a call to this functions which is returned. Okay, so when our outer function returns, we would be having no way to access this private variable separately apart from calling this function. Okay, so let's test it out. Let seeker equals to secret. Okay, so seeker is a function, and if we call seeker, we are going to get the result 42, but we cannot access private, or we cannot access seeker.private or seeker.private, right? So we cannot do anything like that. The only way to access the value of private is to call the anonymous function returned by our enclosing function, right? And this private variable continues to exist even after the secret function has already returned, right? So our 42 value is still persisting, right? So in that particular sense, you can say that closures have a longer life cycle as compared to the enclosing function, right? So this was the easiest example. Now let's move on to a real example. Let's suppose you want to design a counter and you want to maintain the value of the counter as a secret variable, right? You don't want users to access that secret variable where the count is actually stored, but you want to provide users with the mechanism where they can access the value of the counter at any particular moment, but they can never touch or manipulate the value privately without going through your provided mechanism. So let's quickly test it out. How can we design such a counter where users don't have access to the internal mechanism of how a counter value is maintained and what variable is actually storing the value of our counter? So let's create a counter and let it be a function. Okay, and let's create a new variable where we are going to store the value of our counter and let it be initialized to 0. And now we are going to return an object literal. Okay, and this object literal will provide two methods. So we have defined a counter. Now I here is a closure, and these functions have closure over I. Okay, so these functions, which are inner functions, can access I secretly and they can do manipulations on I, but the user who has created an instance of this function won't be able to access I by any means, but he would be able to get the current value of I, right? So the direct manipulation to this variable won't be possible by the user, and in that particular sense you can create variables where you have proper commands over what is actually being done on that particular variable's value, and nobody outside jurisdiction of your can do anything wrong with your private variable that are known as closures. Okay, so let's suppose now we have created a new counter. Okay, we have created a new counter instance. Okay, right? Now if you are going to call counter, it is an object literal which contains two functions, and all of these two functions have closure over this variable I. So if we are going to call counter.get value, we are going to get 0 because the value is 0 as of now. And now let's suppose we want to increment the value. Okay, now the value has been incremented and we can try to re-access the value, and now it is 1, right? So one more thing to notice here is that our internal variable continues to exist even if our outer function has returned, and these functions actually remember the value of I, right? So what can we say about these functions which are having a closure over I is that these functions remember the environment they are created in, and this is generally applicable to all of the closure settings, right? So the internal function remembers the environment they are created in. So for these two functions, I is the environment variable and they remember what the value of I is at any particular moment, right? So this is just a cursory overview of what closures are capable of. Now in JavaScript, closures are used in many places where you want proper command over your environment variables where user cannot directly manipulate them. Okay, now let's have a look at a real gotcha where closures can trip you up, and every newbie or beginner JavaScript developer should be aware of such a scenario where closures can trip you up. Okay, so let's see a practical example. So here is our example which can really trip up a newbie or a beginner developer. So what we are doing here, we have created a function and we have this internal variable I and one more internal variable r, which is an array, and it is going to store some elements. Okay, so what we are doing here, we have initialized a loop, and then in that loop we have incremented the value of I. Everything is fine up till here, right? Now what we are doing here is that we are pushing a new function which is going to print the current value of I at any particular moment to this array. So once this loop is over, this array is going to contain 10 elements because it is going to make 10 iterations, and all of those 10 elements would be functions, and those functions would be having definitions like console.log and print the current value. Then we are returning the array. Then we have created an instance of our a function, and there we have got an array in return, and that array contains 10 functions as we have seen here. Okay, now we are going to iterate over the array, and then we are going to call those functions one by one. I hope I was clear in explaining all of that thing. Now what do you think this program is actually going to print? if we go by any logical means, it is going to first increment the value and it is going to print it, right? Because that is what we have defined our functions to print, right? We are incrementing the value of I here at every single step, and then we have created a function to consume that value of I, and that value of I is incrementing at each and every single step. So according to the logical sequence, we can say that we are going to see 0, 1, 2, 3, 4 and so on as an output. But let's test what it actually prints. So Node.js and whoops. So the current value is 10, 10, 10, 10, 10. What actually happened here? Let's quickly go back to our example. So what actually happened is we have pushed function definition as console.log current value and I. Now once this loop is over, the current value of I is 10, right? So every function has stored the definition where it is accessing the variable I and not its current value at any particular moment, right? So the moment this anonymous function is called, it is going to refer back to the value of I at that particular moment. And once this loop is over and all the functions are pushed to our array, the value of I is 10. And the moment we call this function here, it is going to pass this statement and do its thing and compute the result, and the value of I at that particular moment is 10. So we have got our result as this. Every single value is 10. So how can we actually counter this thing? To do it, we have to employ a technique known as IIFEs, that is immediately invoked function expressions. These are just a normal functions, but those functions are immediately invoked right after defining their expressions or their bodies. To do it, let's suppose we want to change this function into an IIFE. So what do we have to do for it? First we have to remove this expression, and then we are going to enclose this function in a new bracket, and then we are going to pass the value of I. Okay, I hope you can clearly see it. Let me reformat it. Okay, so here we have converted our function into an IIFE. The function is defined first and it is immediately invoked by wrapping that function into these brackets and passing the value of I. Okay, so that function can refer to the value of I because we have talked about the scopes, and this I falls under the scope of this function, and so it can easily access the value of I, right? So let's test it out. Now one thing to notice is that now the array won't be containing function expressions. It will be containing text, and that value will be equal to current value equals to the value of I at any particular moment. Okay, now let's quickly increment the value of I. Okay, and let's test it out. Node.js closures, whoops, and exactly what I told you about. Now the array does not contain any function expression, it only contains strings. Okay, now let's accommodate that change. So we have to remove all of this because we don't need it now. The moment we are going to make a call to our A object, this thing is going to execute, and this statement is going to be executed as well, and we are going to get all of our values. So let's quickly test it out. Okay, now we are getting the correct answer because we have passed the value of I at any particular moment or at any particular iteration, and we have executed the function then and there with the current value of I. So this function is now not referring to the global value of I, but the value of I at any particular iteration. So I hope you must have got some idea about closures. When I started learning about closures, I was pretty confused. So make sure you practice enough about closures, and if you have any doubt regarding the topic, you can leave the comment on this video and I will try to get back to you and rectify all of your doubts. Additionally, I am working on a new course about full stack development, so make sure you subscribe to my channel and press that bell icon so you can get notified whenever I upload a new video on my channel. Thank you all for your time and keep practicing, and if you have any doubt, you have my social media contacts and reach out to me. I will try to help you out. Take care. Bye bye.